In this video we'll dive into the minimum requirements for 2.5.3. Control 2.5.3.1. Logical or physical segregation and segmentation of network segments using firewalls and defense in-depth principles. One way to implement this control is to use a firewall to create different security zones within the network. For example, the organization's internal network could be segmented into a DMZ, demilitarized zone, for external-facing systems, a LAN, local area network, for internal systems, and a VLAN, virtual LAN, for guest access. Additionally, implementing a defense in-depth approach can help to provide multiple layers of protection for the organization's network. Here are top 3 technologies and approaches. Virtual private networks, VPNs. VPNs can be used to create secure, encrypted connections between remote users and the organization's internal network. Network access control, NAC. NAC solutions can be used to enforce policies and restrict access to the network based on user or device characteristics. Firewalls. Hardware or software-based firewalls are commonly used to create security zones and segment networks. Firewalls and intrusion detection, prevention systems, IDPS, can be used to segment and protect different network segments. These solutions can be configured to only allow certain types of traffic to pass through, and to alert or block malicious traffic. Control 2.5.3.2. Network segregation between production, test and development environments. This control is designed to ensure that there is a clear separation between the different environments in which the organization's systems and networks operate. For example, production environments are used to run live systems and processes, while test and development environments are used to test and develop new systems and processes. By keeping these environments separate, organizations can reduce the risk of test or development activities impacting live systems and processes. This can be achieved through the use of virtualization, network segmentation, or even physically separate networks. One way to implement this control is to physically or logically separate the organization's production environment from the test and development environments. This can be achieved by using VLANs, subnets, or by using different IP ranges for each environment. Additionally, access to the production environment should be restricted to only authorized personnel and testing should be done in a sandboxed environment. Here are top 3 technologies and approaches. Network address translation, NAT. NAT can be used to map different IP ranges to different environments. Access control lists, ACLs. ACLs can be used to restrict access. Virtual LAN, VLAN. VLANs can be used to segment a network into different broadcast domains. VLANs, virtual LANs, can be used to create logical segmentation between different environments, such as production, test, and development. This can prevent accidental or malicious access to sensitive data or systems. On Control 2.5.3.3. Secure browsing and internet connectivity. This control is designed to ensure that users are only able to access the internet and other external networks in a secure and controlled manner. This includes restrictions on the use of file storage and sharing websites, as well as remote access websites and suspicious websites. This can be achieved through the use of firewall and intrusion prevention systems, IPS, as well as web filtering and content filtering solutions. Web filters and proxies can be used to restrict access to certain websites and to protect against malicious websites. These solutions can also be configured to block or alert on certain types of traffic, such as file storage or sharing sites. On the fourth Control 2.5.3.4. About wireless network protection using strong authentication and encryption techniques. Organizations can implement a variety of techniques to secure their wireless networks, including using WPA2 Enterprise for authentication, which requires users to provide a username and password before connecting to the network, and using AES encryption to protect data transmitted over the wireless network. Organizations can also conduct a comprehensive risk assessment and management exercise to assess and manage the cyber risks prior to connecting any wireless networks to the organization's internal network. Some of the top technologies for wireless network security include wireless intrusion prevention systems, WIPS, wireless intrusion detection systems, WIDS, and virtual private networks, VPNs. Wireless network access points and controllers can be configured to use strong authentication and encryption methods, such as WPA2 Enterprise with Radius. Additionally, it is important to conduct a risk assessment to identify any potential vulnerabilities before connecting wireless networks to the organization's internal network. Let's move on. Control 2.5.3.5. It's about management and restrictions on network services, protocols and ports. Organizations can implement firewalls and other network security devices to control access to network services and protocols, and to restrict access to specific ports. For example, an organization may block all incoming traffic on port 25, which is used for email, to prevent spam from entering the network. Additionally, organizations can use network access control (NAC) solutions to control access to network resources based on the user's role and device security posture. Network access control (NAC) solutions can be used to manage and restrict access to network services and protocols. This can include blocking or allowing certain ports, protocols, and IP addresses, and can help to prevent unauthorized access or malicious activity. Control 2.5.3.6 is about intrusion prevention systems, IPS. IPS is a network security technology that monitors network traffic for malicious activity and attempts to block or alert on that activity. For example, an IPS may be configured to block traffic from IP addresses that are known to be associated with malicious activity. Some of the top IPS vendors include Cisco, Fortinet, and McAfee. 2.5.3.7 Security of Domain Name Service, DNS. This control is designed to ensure that the organization's DNS infrastructure is protected against cyber risks. This includes protecting the DNS servers themselves, as well as the DNS data and DNS queries. This can be achieved through the use of DNS security solutions, such as DNSSEC and DNS Firewall, as well as through the use of secure DNS protocols, such as DNS over HTTPS, DO, and DNS over TLS. This makes it possible to detect and prevent man-in-the-middle attacks, where an attacker intercepts and alters DNS. 2.5.3.8 Secure Management and Protection of Internet Browsing Channel Against Advanced Persistent Threats, APT. This control is designed to ensure that the organization is protected against advanced persistent threats, APTs, which are specially designed to evade detection and remain undetected on a network for extended periods. This could include using a next-generation firewall, NGFW, which can detect and block APTs, network traffic analysis solutions. This can be achieved through the use of advanced threat protection solutions, such as sandboxing, malware analysis, and threat intelligence. Solutions such as web security gateways, browser isolation, and sandboxing can be used to protect against advanced persistent threats, APTs, that target the Internet browsing channel. It is important to note that these are just a few examples of the many solutions and technologies that organizations can use to implement these controls. The specific solutions and technologies that an organization chooses will depend on their specific needs and environment. Overall, the key to effective network security management is to adopt a proactive approach and stay vigilant in monitoring, maintaining and updating your defenses. It's also important to note that network security is an ongoing process and not a one-time task. In summary, the subdomain 2-5 is an important component of the overall cybersecurity defense for an organization, and it works in conjunction with other subdomains and controls within the ECC to provide a comprehensive defense against cyber risks. It's important to keep in mind that network security management is just one piece of the larger puzzle when it comes to overall cybersecurity.